All right, so we are doing our algorithm for this week. So here's the question. We're going to have to talk a little bit after about some built-in stuff, and then we'll try to build it out. But the question is this. You have intercepted a secret message that was encrypted using a Caesar cipher. The message is, and then it has this message right here. You want to know that the cipher used a shift of 3, or you know that the cipher used a shift of 3. Your task is to decrypt this message. What does the original message say? So a couple hints is you can use Python code provided in the lecture to decrypt the message. Yep, obviously you can do that. Some of the things that you've known. Some other hints, and these are going to be two really important ones, is that Python has a built-in function called ORD that converts a character to its Unicode code. And we're going to talk about what this Unicode code means here in a second. And another built-in function called char that converts a Unicode code to a character. So does anybody know what is Unicode? Does anybody know what a Unicode code is? Any thoughts or ideas? No wrong answers?
Never heard of it.
Okay. Well, does anybody know how let's kind of start way back at the beginning. Does anybody know how a computer stores information? Think about any hacker movie or hacker like thing. There's kind of two ways it can store an information, or two pieces of information it has.
Encrypt, decrypt.
Sorry, there's two what were they? Sorry. So two of you talked at the same time. Okay, well, computers store information in the form of binary code. Does anybody know what binary code is? It's just made up of zeros and ones.
Zero
right?
and one.
Yeah, that's the only way a computer stores information. And so knowing that, we have to say, well, how does it know that this is a C? And more importantly, that this is a lowercase c and that this is a capital P. Well, what scientists did way back in the day, code numbers, is they said, you know what? There's so many different things from emojis to exclamation points to characters. We can actually just assign each number to a specific, let me go back here. We can assign each letter a number. And the way that they do that is they use this thing called ASCII code to give it a Unicode number. Again, this is a uniform way. So that way, wherever you are in the world, you use Unicode. So that way it can decipher and say, okay, an A here is an A in England or France or wherever. And so you can see that every number is given this, or every letter is given this number, right? And what's good about that and why that's necessary is because then a computer can convert that number into binary code and store it. So this is the binary code for the number 65. This is the binary code for the number 66. It's on a base 2 scale. And so you go all the way up, there's 60, and then there's add 64, and then you add another 2, and that's 6. And so we can do that for every single letter, right? Every single letter has a numeric value associated. Now, because of this, and if we look here at this actual character table, we can see that a lowercase a has a different ASCII code than a uppercase a. And so whenever you see strings and we're comparing strings, or we're comparing, words, if they are different, if one's capital and one's lowercase, it's saying, hey, they're not the same, because all a computer sees is 65 the same as 97? It's not, right? We know, hey, lowercase a and uppercase a, they're still the same letter, just different, but a computer sees, nope, that's a different number than that. So with that knowledge, what we can do is we have the ability using ORD, using the ORD method built in, we can say, hey, if we have a character, if we have a letter, give me the ASCII code. Give me the ASCII code here. And that's what ORD will give. So if I were to say something like print ORD of A, and I were to run this, we get the number 65. And it was an uppercase A. Same thing if I do E, I should get the number 69. An uppercase E specifically. Cool. But if I do a lowercase e, I get the number 101, and we look at this table, and yep, it is number 101. So by knowing this, we go back to our question, right? It says we have intercepted a secret message that was encrypted using a Caesar cipher. This message is this one right here. You know that the cipher is used a shift of 3. Now what that means is if we wanted to, let's, I guess, take this capital F is 70, right? A shift of 3 means that we're going to go back 1, 2, 3, and it's going to represent C, capital C. And we're going to do that for all of the letters. Okay, how are we feeling? Are you guys overwhelmed? Are you so confused right now? There's a lot of information I just gave you.
Well, it's all new.
Yeah, it's all brand new.
The binary codes between numbers 65 through like 68, why are they so different? I think it was number 67.
Yeah, great question. So this is base 2. And so meaning that this represents 2 by 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 2. And so there should be 8 here. 1, 2, 3, 4. Yeah. So this is an 8-bit. So if we go through here, 8 groups of bits is called a byte. Long story short, this is a way that I can represent. This represents the number because it goes, I believe it's 2 and then 4, 8, 16. And then you can keep going and you can identify where this number is. So based off where this number is, you can, or based off where the ones are, using this binary code, you can identify, okay, this is 65. This represents the number 65 because this is on a base 2 scale. Does that make sense?
Yeah, I mean, I'm just looking at, I'm looking at the binary code for C and D, and it looks like D ought to be C, just logically looking at the binary code between 65 and 66, you know, you think that it'll shift over another 0, and it kind of just goes to 1, 1, you know, instead of 1, 0, 0.
Sure. This is a wonderful lecture. CS50 is sort of like a legendary lecture. And I'm happy to at another point, especially when we get to projects and algorithms, I'm going to really dive in and kind of try to do as much as I can with you guys that normally we don't talk about, where we talk about like memory and binary, stuff like that. Because I think it's important to know. For the sake of getting this algorithm done, and I can also talk about binary next week as well. We can kind of jump into that. And why don't we do this next Thursday? Why don't we learn binary? That'll be sorry, not next Thursday, next Wednesday. We'll like learn binary and try to understand that from an algorithm perspective. Because I think that's gonna fare you much, much better than going through a list, something like that. And so I'll teach you binary and then maybe talk about memory a little bit. Would that work?
Sure.
Cool. In the meantime, there is a YouTube video that I just put in the chat. That's CS50. Again, it's super long, but here, this section from 16 to 28 is all about binary. And so it's a little 12-minute video that'll teach you all about binary, how you do it and how you count for it. So I'll explain it for you. Okay. So coming back to this. So we know a few things.
So there's
right?
a lot of different ways to learn data.
Oh, there you go. Somebody who's already watching it. I love it. Cool. So we know that here's our message, right? Here's what we have. We know that there are some built-in functionalities that are going to give us some of these numbers. And we know that there's a shift of 3. So we know now we can identify in the same way that I saw this F. I can just write an algorithm that takes that letter and says, okay, I want to go back 1, 2, 3. Cool. It's C. And because I know I wrote this, that is the letter C. And so let's write this. Let's kind of start from the beginning and see if we can, at first, even see if we can, get each Unicode number, and we'll kind of check a couple of them. We'll see if we can get each Unicode number, and then we can kind of continue from there. So what's my first thing I would do? First thing I would do.
Loop.
I'm going to loop. Yeah, that's absolutely a loop.
Mm-hmm.
But I need to create a function, right?
Mm-hmm. Yeah.
And what is going to be crucial for this function that's my cipher, right? Because I want to be able to put a bunch of messages and it always work. What are the 2 pieces of things that I need in order for me to be able to decipher this?
The text character.
I need these characters, right? I need this string. I need my encrypted message. And then what is the big thing that I needed? What kind of tells us what is my secret to cracking this cipher? How did I am shifting from F to C. So I need my shift number, right? Cool. So let's go do that. Let's create this. We're just going to call this decrypt. And then we're going to say, it's going to take in message. Again, this could be anything. This is just a parameter. So it could be unicorn, it could be cupcake, it could be anything. But we're going to call it message and shift because that makes sense. Now, I'm eventually going to decrypt this, right? I'm going to decrypt it. And I'm going to have a new decrypted string. So I need to create a decrypted, let me turn this off. I need to create a decrypted string, right? I need to create a string so that way when I decrypt each letter, I can go ahead and do that. So I'm going to say decrypted, DECRYPT. Cool. So I have that. Doesn't equal anything yet, but it's a decrypted string. And so I've got, again, right now, we just want to see, can we get the Unicode number for this? And then we'll put in our logic. So just like Tenzin said, what am I going to need to do in order to go through each letter of this string?
You have to loop through it.
Exactly. Exactly. So I'm going to say for char, that's going to represent character. I could say character, but char is a little bit easier. In message. And first and foremost, let's just print char. Let's just make sure it's working. Cool. That's all I want to do for right now. And I'm going to say decrypt. I'm going to call my function. I give it this guy right here. Perfect. So now I come up here, I run this, and I get that, right? I get F, R, G, L, Q, J. Perfect. F, R, Z, U, X, whatever. Cool. So I know I'm able to iterate through my message that rules. Now we said we wanted to see eventually where we can or what that value is. I want to get the Unicode value of this. So knowing that there are these built-in methods, how would I do that? Knowing that there are these built-in methods, how would I get that?
You have to create a table that stores it.
Right now I just want to visualize it. Good idea. But in the same way
Maybe
I
creating a
visualized
variable.
this, in the same way I visualized it this way, all I want to see is instead of the actual letter, I want to see the ASCII code. Now, what method here converts that to a Unicode or ASCII code?
Or
Or, exactly. So I can just say this of my character, and it's going to print the ASCII code or Unicode version of this specific character. So if I clear this, I run it, now I get 70, which if we check real quick, we know that it's capital F, it's capital F 70. It is perfect. It is R, lowercase r for 114. I'm just gonna check this one. Yep, it is. Okay, so I can assume that it's working. I'm able to get these numbers. That's awesome. That's awesome. Great. Now, there's two tables that I need to do. Or there's two things I need to do, right? Actually, I kind of think of a different way. I already have the answer, but I think of a different way I want to kind of get it. What if I create a new string or add to my decrypted string just these numbers here? Do I want to add these numbers, or what is the kind of shift I want to do?
We have to shift 3.
Exactly. Exactly. So what if I did this? If I do this minus 3, what's that do for us? Let's try that. Let's see if this gets us 67. Now we get 67, which is a C. Yep. 111, which is an O. Perfect. 100, which is a D. Okay, perfect. So now I know this. What if I added those numbers to this string? And then we would have our decrypted code, or it's in the Unicode way, but it's still decrypted. And eventually I can go and do that back. So let's try this. Okay. Let's see what happens here. Oh. I think I just say,
Plus equal.
yeah, I was gonna say, I think it's just plus equals. Let's try this. Oh, concatenate string to not int. So I could just say str, I can cast that to a string. Okay, So I get that. Makes sense. Now I could do something else though, right? Where instead of concatenating this to this string and then going through, does anybody see the error or the issue I would have if I tried to then iterate through this? What could
We
cause
will
an issue
iterate
here?
only single number, so we couldn't find.
Yeah. Exactly. There's no way for us to identify if this is 11 or 111 or 100 or, 671. There's no really way for us to identify this. So what we could do is we have another built-in method that we know is available, right? Called this. So what if we just say, I think it's char, right? Yep. We just say this. What if we just say this? Let's see what this is. All right. So now we have decrypted our message. Now there's things that we can do to make this better. Like there's lots of things that we can check and edge cases, which we can bring up. But there's ways that we can make this better. But for right now, we have decrypted our message. We have used the Unicode and ASCII binary table to take this encrypted message and decrypt it to coding cow rules. I'm going to pause there. How are we feeling? What are we thinking?
Can we put shift instead of 3?
We could. Yep. That's a great one. I could put shift and we still get the same thing. And that's more dynamic, right? Because what if I would have said 4? I don't know what this is going to be, but it'll be jumbled up. So it doesn't mean anything, but you could see that it shifted because we went to B, N, C, et cetera, et cetera, et cetera. Yeah, great call there. Cool. Now, I don't have any spaces here, but I have spaces up here. So what could I do to kind of do that? How can I get those spaces here? Any thoughts? I remember whenever I did this, right there for right now. When I did this, I got the spaces. So my character at this point is just a space. So what could I do?
Does it make sense to do print decrypted string plus char?
It could.
Or like append char or something?
We could do that. What if we created a condition in here? So just kind of like what you're saying, let's create a condition. I say if char equals, I think it's declarative. space. Then I think exactly like what you're saying, Gregory. I could say decrypted string plus char. Now I could have an else here. And say, if not, then do this. That works fine. Except that would have to be over there. But let's see if this works, and then I'll show you a different way we could do it. Let's see if this works first and foremost. Let's clear this actually. Coding cow rules. Cool. So we were able to look at the character and say, great, if this happened, that's awesome. Let's go ahead and add that space. And if not, if it's not a space, meaning that it's an actual letter, then let's go ahead and do our shift and change that. Another way we could have done this, just without having an else, is there's a cool tool called continue. And so let's see if that works. It's the exact same. Anybody know what continue means? Once
That kind of takes the place of the else, right? So it's like disregard everything else if the criteria are met.
sort of, yes, in a way. One thing I want to distinguish is if I had it like an else here, you know, and then I still had something below this, you know, print X, or, you know, print 35, I don't know, something random. If I have an if else here, let's say that I comment this out. If I have an if else, it's going to hit one of these because this is my chain, but it's still going to go to something outside of my conditional statement. Right? It's either going to hit this one or it's going to hit this one, but then it's going to get to line 18 and it's going to do that. What continue will do is say, hey, I want you to forget the rest of my for loop. So it'll skip this print 35. And it'll skip, obviously, this too. But by doing that, I can just say, hey, I don't need an else statement. Because if it is a space, well, I don't need to decode anything, so let's just skip it. We'll go up, and then the next character will happen. Either it will hit this if statement or it won't, and then it'll do this. So continue sort of as like it exits that iteration of the loop and goes on to the next iteration. So we can see, let's see if this. Okay, yeah. So there's 1, 2, 3, 4, 5, 6, 7, 10, 11, 16. Yeah. And I would bet that there is 13 35. This is a terrible example, but here, I'll do this. Let's give us a little bit more. Cool. So you see that it only prints, it doesn't print 35 by itself, right? If it gets here, and you notice it doesn't print even any spaces, because this is still a space, right? This is still a character, but it doesn't print any spaces, which tells us that it continued, and it doesn't count that at all. Does that make sense?
Yeah.
Cool. So we have created our own Caesar cipher, where we can take in a ciphered message with a shift of 3. And we have decrypted that. And so cool, now we have our secret message. Any questions on that?
Yeah. So the point of the continue,
Mhm.
that's essentially if you just want to skip like a if else statement, could it be used
It's
for
not,
other applications or
it's not, yeah, so it's not even an if else statement. It's if you have a bunch of functionalities that are happening. So let's say I had a whole bunch of code, but I'm saying, hey, once this happens, I don't need to decode and do a whole bunch of stuff. I just want to go to the next letter. What continue will do is it'll stop that specific iteration. And so it'll forget again, even if I had 100 lines of code, it'll just go straight to the next character or the next iteration of my for loop. There's
Okay.
another one as well, called break. What this will do is this will break out of my for loop. So we can actually see this here. It's clear. It'll do the first one. Oops. We get coding. And then when I get to my first space, right, because I start with coding. When I get to my first space, it enters my if statement. It adds the characters. So I don't know if you could tell, but there's actually a space here. And then it breaks. This means I want you to exit my for loop and it's done. It's like a premature exit. So really those two, continue and break, are really, they're used a lot. So I wanted to make sure you guys are aware of those. But again, all it does is this breaks out. This fully breaks out, leaves my for loop. Continue just goes on to the next iteration. And skips the rest of the for loop for that iteration. Does that make sense?
Yeah. In fact, is there a way to tell it where to break? So if you wanted to get more of the original code there, like coding cow, and then leave out rules, or put like coding rules, leave out cow. Is there a way to do that?
Yeah, you could do something like this. So if you, well, you couldn't leave and then come back. So that would just be like a statement. But if you said, like, if you wanted to stop at coding rules, right? You want to forget or coding cow. You want to stop at coding cow. You could say something like, if decrypted string equals break. Where you're still doing all this stuff now, but if I come here, no. Oh, no. Why is that? Oh, anybody see my error?
You put a space before coding.
Yep, 100%. If decrypted string. Ah, now I've got a second. This one's a little bit more of a challenge. Anybody see the error of what it could be? Think about what happened when I did my first break. What happened? What did I point out? What is line 13 and 14 doing?
Your alignment's off.
For what, I'm sorry?
The first decrypted string under chart, it's not aligned.
Well, that's okay. It's because it's indented, right? I don't
Oh.
know why. Yeah, I don't know why it's. Yeah, it's still tabbed over. You're fine. But that's fine. But what is this line doing?
So
What's
if the
this line doing?
character is a space,
So it's checking. First off, it's checking.
Space.
Oops. Checking if the character is a space. And then what is this line doing?
Just adding the space character.
Okay. So adding the space, right?
Mhm.
Oops. Now, let's say we get to coding cow.
No, there's no way that we can go there. We can get there.
There's no way we can get there, right?
We only got the
Bec-
space.
Yeah, exactly. Because this is after this part. We get to coding cow down here, right? When it's a W. And then we add that to my decrypted. We come up. The next one is a space, right? And so what's happening is because this line or these two lines are before these two lines, what this does is this goes in and now my string is not coding cow, but it's coding cow space, right? It added that here. So now if I run it, oh my gosh, what is happening? Coding cow. Let's see what's happening here. Because what my thought was, is if I just swapped these two, it would break. Or if I added the space here. So this is going to be tedious, but let's go ahead and try it. Coding cow. Coding cow, coding cow R. Did I spell that incorrectly? No. See, we get the 35. That's this. So I would have thought right here that would have stopped. Rob, do you see anything?
No.
Because it gets to a point where it is coding cow, which means that it enters in and it gets to a point where it's coding cow space. So let's try it. Let's see if I just swap it.
Why are we printing 35?
Oh, that was just a random. I just wanted to print something to show and I didn't have X, so I just put 35, which is it's just a random number, random character. Let's see if I put this up. What happens? Nope, we're still getting that.
And when you run it, it's all lowercase coding code, so it should, or it's title case.
Yeah.
What is that?
Oh,
Right.
it's a tool that I use to oops. Okay.
Would it matter, Will, if it so you have if it's that break, what if we put an else statement? But it should stop on that break either way.
I'm wondering if this break is encapsulated with this if statement
Maybe.
and
That's a
not in my
good point.
for loop.
Oh, yeah.
If I were to say something like, because this is going to break out of this, not in this. Because if I just go here, let's comment this up. I come here and I say break. As you can see, this is exactly what I thought. So what it looked like is because this break is in my if statement, it is encapsulated with this if statement. So it'll break out of the if. And so it was one layer deep. So if you think of like an onion, right? It was just one layer too deep for us to see or for the for loop to see. So it didn't belong to the for loop. Now one layer out. So within my for loop, when I break, I go and I decrypt that. It now breaks my for loop. This is where we would have to say, if we wanted to do that, let's try a few things. I'm going to try something and then we'll ask old chat GPT. So we can say something like this. We can say if what do I call this? Decrypted string.
Mhm.
Let's see. That's exactly what we did, right?
Yeah.
Oh, I didn't save that. No, still got coding cow rules. Let's check it. Okay. See, that's why I'm confused. Because this says break statement is put inside the loop body, generally after an if condition, which is exactly what we did. It terminates the current loop in which it appears, and resumes execution at the next statement immediately after the end of that loop. Let's see this.
Yeah, I was gonna say, can we run a print statement on it to see? Or did you?
We
I don't
did run a
remember.
print statement to try to see what it was. Let's just see. So it's not even entering that.
What if you put the,
Mm,
what if,
here we go. I think I figured it out. Oops. Let's try. Okay. All right. Woohoo! We figured it out. Okay. What was happening was, you can't really tell, but here what was happening is I have this if statement, and because remember I took out this continue. They're saying if this is this, then we're gonna add, or if it's a space, we're gonna just add that space to my character, or to my decrypted string, which is great, right? That's what we wanted. Because I didn't have my continue, it was then coming down here and adding in an additional space, because I was adding in an additional space. So it never was coding cow. Let's try this. I'm going to see if my theory is right. If I add in an additional space here and I comment this out, does it still work? No. Okay. I'm lost for words now. So this works.
it's because you're not checking for the double space though, Will.
I just did. I just added 2 spaces here. And if I don't have this and I check it, I get coding cow rules. So I'm not even entering. So like if I print in my break condition, even if I have this, see, it's not entering that. So when it gets to a space, saying if the character is a space, we add that space. Then I add, let's print. Decrypted string. Let's just say, I want to make sure that this is working. Okay, so we're getting to coding, but see, we're getting coding twice. Oh yeah, getting everything twice. Okay, so if I put a space here, it automatically doesn't work anymore, even though that happens. About a continue statement, you just get to coding cow. So there's something wrong with this line being after this. See if this is still the case. Okay. So something was happening where this decrypted string plus equals this was giving me something additional that made it not equal coding cow. I don't know what though. I can't figure that part out and we're at class time. So we have two options. We could either do a continue statement that prevented this line from running when there was a space, or we could have an else statement. And then it's the same sort of thing. And that fixes it. I'm almost stuck to why that wouldn't work or what that was doing, but we don't have time to dive in. Are there any questions? I know that was kind of like we went down a rabbit hole to try to figure that out, but are there any questions on this? Any questions or thoughts? Was this way too confusing?
I'm
That
lost
was a
as hell,
shock.
man. I'm lost.
Well, I would be curious if we move the line 20 up to line 13 and then made line 13 an Aleph to see if it would change that.
Let's try it. So that still works. Let's see, this is what the big deal was, is we didn't have that. So we need to continue. Or else it's gonna do something weird. Yep, see. So something to do with this
Yeah.
line is we're adding the character ord. What if we're adding nothing though? I wonder if that's what's messing us up. Gregory, did you say that you were super confused or that you really loved this? I'm so sorry. I didn't quite catch that.
I was saying how like this is a shock, and I am lost. I was agreeing with Graylin there.
What did you say, Graylin?
Yeah, I'm lost as hell, man. I don't. I'm like, this is over my head right now.
Okay. I will make sure that I dial it back on the next ones.
I mean, it's cool. It's cool to get this exposure.
Sure.
Like I was good with the ASCII and
But
like learning, hearing that all makes sense. But I'll be honest, like algorithms is like my weakest area, so don't go by me.
Sure. Sure. And this is the challenging stuff, yeah, this stuff is real challenging. So, okay. I will stop the recording there and then we'll get started with class. Give me just 1 second.